Today we're diving into something called runtime intelligence. It's a really interesting approach to AI-driven security, and it tackles a major headache in AI-powered remediation by giving it the one thing it's desperately missing: real-world context.
So let's start with a big question. We're all seeing AI being used more and more to speed up fixing security vulnerabilities. But here's the problem. A huge number of these AI-generated fixes just fail the moment they're deployed into a live environment. They might look perfect on paper, but in practice, they often end up breaking the application. And the reason why is surprisingly simple. They're missing one absolutely crucial element: runtime context. The AI models that are creating these fixes, well, they have no idea how your application actually behaves in the wild, under a real workload, with real production data. This blind spot, this missing context, is the root of the whole problem. Now, this lack of context becomes a much bigger deal when you look at the sheer scale of the vulnerability challenge. The truth is, new vulnerabilities are being discovered way faster than teams can fix them. This creates a constantly widening gap and a backlog that just keeps growing for security and dev teams.
Just look at these numbers. On average, a typical app gets hit with about 17 or 18 new vulnerabilities every single month. And in that same time frame, how many do teams manage to fix? About 6. You can see the problem right there, right? You're falling further and further behind each month. So, these generic, context-free AI fixes, they're often useless. The AI simply doesn't know about your application's specific database framework or any unique tweaks you've made or how it integrates with other services. So what does it do? It spits out a standard, one-size-fits-all patch that's completely incompatible with your production environment, and a developer has to go in and rework the entire thing from scratch.
Okay, so if the problem is missing context, the solution is pretty clear. We need to give the AI a detailed and accurate source of it. And that is exactly what runtime intelligence is designed to do.
So what is it exactly? Well, runtime intelligence is all about gathering real-time data from an application while it's actually running in production. Think of it like this. Instead of just reading the static blueprints, the source code, you're watching the application live. You're seeing which code paths are actually being used, how data is flowing through the system, and what its real-world performance looks like. It creates a living, breathing model of your app's behavior. And it captures a few key things. It sees the exact code paths that users are triggering. It tracks how data moves from one function to another. It figures out what frameworks and libraries are actually being used, not just what's listed in a file somewhere. And, maybe most importantly, it helps you figure out which vulnerabilities are genuinely a threat in your specific environment, filtering out all that theoretical noise.
The best way to see the impact of this is to compare two different ways of fixing the same problem. Let's take a classic SQL injection vulnerability and see how a traditional AI approach stacks up against one that's powered by runtime intelligence.
Okay, so first up, the traditional method. A static analysis scanner, the usual tool, flags a potential SQL injection vulnerability in the code. Then, an AI tool gets the job of generating a fix. So the AI gets a report, but it only has the file and line number. That's it. Based on that tiny scrap of information, it creates a standard fix, maybe a parameterized query. But when that fix gets deployed, boom, the application breaks. Why? Because it's incompatible with the specific database framework being used. Now, a developer has to stop what they're doing, figure out why it broke, and manually rewrite the whole fix.
All right, let's hit rewind. Now we're going to tackle that exact same vulnerability, but this time, our AI has access to the full picture from the runtime environment. In this world, the vulnerability is spotted while the code is actually running. The AI gets the complete context, the exact code path, the data that triggered it, and the specific database framework. With all that intelligence, it generates a precise fix that's perfectly optimized for that setup. And the result? The fix deploys cleanly. No rework, no application failure, it just works. You can really see the difference when you put them side by side. Your source of truth shifts from static code to live behavior. The fix accuracy goes from a generic template to a solution that's tailor-made for your environment. And the deployment time, it drops from hours of manual work down to just minutes. The AI goes from knowing nothing about your stack to understanding it completely. So this isn't just a theoretical improvement. This approach has a real, measurable impact on security operations. When you give AI this runtime context, the results are, well, they're pretty dramatic. Get this.
Organizations using this approach see an average reduction of 87% in their mean time to remediate vulnerabilities. That is huge. You're taking a process that usually takes months and shrinking it down dramatically.
And for the really critical stuff, the traditional time to fix a critical vulnerability is about 84 days, almost 3 months. With a runtime-powered approach, you're talking hours or days. That directly slashes the amount of time you're exposed to your biggest risks.
And it's not just about speed. There are other major benefits. First, developers actually trust the fixes because they're based on how the app really works. Second, you can scale this up. The AI can generate hundreds of tailored fixes at the same time. And third, your accuracy goes through the roof because you're validating risks against running code, which practically eliminates false positives. So you might be wondering, okay, this sounds great, but is it hard to set up? Well, the implementation process is actually designed to be pretty lightweight and plug right into the workflows you already have. It starts with a quick assessment to see where your current bottlenecks are. Then you deploy these lightweight sensors, usually right through your existing CI/CD pipeline, so no code changes needed. You let those sensors just watch your application in production and build up that intelligence model. Then you connect that context to your AI remediation tool. The last step is just to validate the results and measure the huge improvements in fix accuracy and speed. So I'll leave you with a thought. Having a complete, real-time model of how your application actually behaves is a game changer. That shift from just analyzing static code to understanding the dynamic, living system, well, it completely changes the relationship between your developers, your security team, and the software itself. It really makes you think, doesn't it?